Hello, everybody. How are you doing? Sorry, a little close to the start time today. I had to get home from the campus, and so I had forgotten my laptop charger. I'm good, thank you. It snowed a little bit in Moreno Valley today. I heard it's snowing everywhere, so. Okay, so as we have more people coming in, we are going to do the assignment today. I'll walk you through some of the coding for Python. So we are covering chapter 2 today. Okay, so go ahead and log into Canvas, download the notes and the assignment, and we'll go through that together. Yeah, I just finished a class at about 4:30 and try to get home. Okay. Let me get to screen share real quick here. So in this week, we are going to cover a little bit more on the library or the module that we can use from Python. In chapter 2, it touches on different types of modules, starting with your Sys module. I think where we left off in chapter 1, we touch on what a module would be. So simply a module is just a Python file. You can customize your own module, or you can simply use some of the pre-created either from Python or from another developer to be able to pursue your objective of your program. To start, we'll talk about the Sys module, and Sys module is useful, especially when you want to have information about your interpreter and also using some of the arguments. So here it talks about Sys module. It allows us to interact with the interpreter. It contains information about the execution. It also allow you to utilize function that would be on the low level. So here I included a link, and if you click that link, it's going to take you to the documentation of Sys. And there are many different methods that you can use. So for example, you can use audit, you can use, so these are the list of functions or methods that you can implement when you bring in the module, when you import in the module in your script. Okay, so we will take a look at how we would be able to incorporate this. And so in the actual notes, it shows you an example. And in this example, we are going to use arguments. And so arguments can contain the command line. And the way that Python treats the argument is with the argv here. Okay. And it would treat it as a group of items in a list. So the first index is going to give you the name of your script itself. So this is a way that we can use an argument to find out our program information or our module information or our script information. Okay. So when you're using the index 0 with the arguments, you are accessing the information or the name of that script. And then the subsequent argument, you just increase the index, and that will be able to allow you to pass different arguments. So if we pass 3 or more arguments, that will contain at least 4 objects. So when you write your script using Sys module, the first line on your script should always be the import statement. And you can use the from statement if you're pulling specific component from that module. So here we're going to bring in the entire module by using the import sys. And we're going to use the print method to really display some of the information, such as the name of your script. So if you want to list the name of your script, you would use the index 0 for the argument. And you simply use the sys.argv. And then in the square bracket, we would put the index value, which is 0, that would automatically give you the name of the script. And then in the second line here, we are using the argument. And in this one, we simply use that with length. And that is going to give us a list of arguments. So if you need to really check, right, your script, how many arguments are you including? So it's going to refer to the number of arguments and it's going to return that here. Okay. And then we'll run the program to show you. And so let me get the example one up here for you to see. So this is the program that we're using in the example and in the textbook. Okay. So as we run this program, I don't know why it's telling me that now. Oh, so here I'm getting a little bit of track back. Let me double check my thing here. What's the first argument? Yeah, it stops at line 5. So let me comment that out real quick and just rerun it. Oh, I understand why now. So because I don't have these components, it's gonna not want to be able to list that. So let's see. If we're only using this, it's gonna give us our file name, our Python file name. So index 0 is gonna give you your file name. Index, when you're using the sys.argv like this with the length, what it's going to do is going to check your script and it's going to determine the number of arguments. Since I only have one argument, it's only going to give me one. So if you're using more than one argument, it's going to give you that value here. In the next line, what we're going to have is we are going to have the we're going to use just simply sys.argv again. And here, what we're going to do is we're going to parse it into string. And that's different than what we were seeing with the line 2 here, where in line 2, it simply gives you the file name in its entirety. On line 4, when you parse it with the string, what that does is it's going to put it into a string here. And so it tells you that that argument, right, which consists of your script name, and it's going to parse it into the string for you by putting it into quotation mark, and then it's going to include that as a list. Okay. Now, earlier you saw that I'm getting an error because it's going to ask for the first argument. So truly, I don't have a second argument, which is going to be index 1. So that's why it's throwing an error. And then the subsequent argument after my file name, the next index, I don't have that. So if you have more than the initial right name, if I have additional arguments, it's going to be able to run these lines. Okay, so when you test the script, it might throw an error in the case that we don't have more than one argument. So the line 5 and 6 that you see here, that will not run. Okay. Any question regarding example 1? Now, in the second example, we continue to use the Sys module. So you can find additional information about variables. And when the system creates the variables, all that is it's going to take a space, an address in your memory, and it's going to associate that address to your variable name, okay? But in this case, we also wanted to check your system information, like the version of your Python, your encoding, your, it's a typo here, your encoding, your, what was it? Your platform, like your OS. And so as we look into security, we can use Python script to really output, right? The platform that we're running on. We can find out more on how, right, your environment variable is set up. So it's going to go back to the OS and it's going to look at some of the information that's going to be given to us by the OS. So those are going to be the properties of your system information, your system overall. Okay. So let me load number 2 here so you can see. And again, you can download the script from the link that I provided in Unit 1 notes. So again, we have the import sys statement at the top as we are using that module. We're going to use the sys.platform to going to give us the OS information, the platform we're running. So if you're using Windows, it's going to tell you Windows, right? And let me clear this so I can run it for you. So here it tells me that it is Win32. Okay, that will be the platform here. And then it's gonna give me the Python version. Now the standard output for the right here, what that is I don't have any standard output, so it gives me none. The encoding, we would see that the type of encoding system that we're using is going to be UTF-8. So if you want to find out the type of encoding for your system and the default, you can use sys.get file encoding and then get default encoding. So sometimes that will be different. Okay. In this case, it's exactly the same. So you're using the same encoding as a default encoding. Now, this is going to issue this method. Usually it's just going to issue the same command that you would use in command line as Python. So when you have Python installed, if you type in Python version, right, Python-V, it's going to give you the same thing. So what this does is this method actually execute the command, right, and then be able to return the information. So this is why it shows that I'm using version 3.77 with my Tani. Okay. And it also included a little bit more information on the architecture that I'm using. So that gives you a little bit more detail. Now, your environment path, this is tied to how it execute my packages for Python. So if you don't have the environment path, right, it won't be able to print that out. But as we install that, it's tied to an environment variable. So you simply use a sys path in order to find that information. So it gives you here, right, the location or the path of where the packages that I'm using to run my script. Okay, any question with number 2? Okay, so in that example, we saw how sys can also be implemented in the script. And there are a lot more if you look at the documentation on how you can use different built-in methods from that module. And we simply import it, and then we can utilize some of the functions or the methods that's already pre-written there. So if you want to return the current OS, we would use platform, the version, the encoding, as we talked about that. Okay. Now, in the first question of your assignment, it's going to ask you to do something similar to example 1 and 2. So we are going to use our Sys module and arguments and variables to be able to display our script name for A. We're going to look at the number of arguments used in the script. We're going to display the OS platform information. We're going to look at your package version. And we're going to look at the default encoding system. And we're going to display the environment variable path. So you can pull some of the tasks from your example. Okay, so I'll show you the script that I have. Okay, so we start with using the import sys statement at the top because that's a module we're using. And like the example, we want to find our script name, your file name, the Python file that you're using. So we simply use print, and then I added a string name of my script. And after that, we would do a comma, and we would want to use the argument with the index 0. Okay, just like the example. That will take care of the first task, task A. For 2B, we are going to print out the number of arguments in the script. So in this one, again, we're going to use the print method. And we want to say the number of arguments in the script, which is a string, and then comma. And if you don't have to include the string, you can, so that way you know what it means. And we simply use length with the sys arg v as a parameter for length. So it's going to look through the list of your arguments, and it's going to determine the number of items in that list, and that's how it's going to be able to return. Then we're going to use the platform for 2C, and for the 2C is going to be you simply just do a print with the sys platform, very much like the example. Then for Python version, for the 2D, we simply print, and we can add a string Python package version, and that's your sys.version. So as you use the Sys module, you consistently see that we would incorporate the module and then the methods from that module, so that way we can have a specific output, such as Python version. Yes, so when you use the 0, it's always going to be your script name. Okay, that 0 index with the argv, the argv, that's always going to be the name of your script. Okay, and then if you have additional arguments in your program, which we don't, right? It's you can use specific index to identify the arguments. So your encoding is always going to be, the system that you use for your program to encode. And so what that does is it does a conversion to convert from, you're welcome, from your low level into what we would see as text or things that can be visible to humans. So my default encoding, right? So you don't have to put this line. So I'm going to comment that out, because in the exercise, it only asks for the default. So are we going to use the sys.getDefault encoding method to get the information about our encoding system that is default? And we simply put that into a print method, so that way we can see the output. And lastly, for 2F, we want to see the environment variable path. So you simply use a sys.path. So it's pretty straightforward. The way that they created these methods are pretty standard, and it's really resemble what you would require for it to output. So when we run this, right, we're getting something similar to the example. I have my Python file, which is U2 exercise 1, unit 2 exercise 1.py here. So that will be my index 0. That's always going to be your script name. Now, how is this applied, right? In the case where you would have many different scripts that work together. So for example, or you can build a package, which can might include multiple modules. So in that case, we can incorporate a statement that's simply using a Sys module to give us more information about that individual module. Then again, for next line, we saw that there's one argument. There's Win32 for the OS platform, your Python version number and information, okay? And then the default UTF-8 encoding system, and then lastly, environment variable. And that is, you know, where your Python packages live, okay? And so when you set up environment variable for applications, or especially like if you're using certain programming language package, what that does is it's going to link that to, you can use that to the environment variable to link that path to a specific application. So for all the Python for Tawny, I'm using Python 3.77, and it's located at that path. Okay. Any question with exercise 1? So we simply refer to example 1 and 2 for unit 1 exercise. You can take pieces of those example and using the Sys module. So I want you to practice. That's why we're doing these exercises. So in the case that you need to find information about your platform, your Python version, you would know how to do that. And in command line, we can use certain commands for Python to be able to execute certain things, but you can definitely write a script in order to pull some of the information. All right. In the next part, it touches on OS module. And here is where we can dive a little deeper in finding operating system. And in security, we do need some of the information about the OS, right? You see this with when you're using Nmap, or when you're using a certain scanner, it would go and look at the target system, and it's going to give you some information about the target system. And the documentation for the OS module is here. So there are a lot of different things that you can do with the OS module, okay? And it goes and it talks about how you can look at processes. You can also find specific information about the environment variable, path, and so on. Execution path, especially with a certain OS, right? And keep in mind that they developed this to really work with Unix and Linux-based systems. So it is more friendly with the Linux and the Unix-based system. So if you go further, some of the things that might be important for security, like get group list, so you can look at the group in that OS, you know how on that system you would create the user, get groups associated with certain processes. Login, you can do a get login, okay? And that allows you to get additional information about, you know, a specific user credential. So this module is useful in our case. Get UID. There are a lot of things that we can touch on using this module. Okay, so if you like, you can practice using your Linux virtual machine, write some script, test it. Okay. Now here it says that in our notes, it says that there are different commands in different OSs, and we know that, right? Like for example, if you're using something like ipconfig or ipconfig all in Windows to get IP configuration or your network adapter information, that is different in Linux and Mac OS. So overall, your OS module really is a way for us to incorporate functionality that will interact with the OS itself in our Python program or script. Like we can look at file system permissions. We can take a look at specific file. So this is closer to the command level where it uses command line based arguments. Okay. So the example here, what they're doing is they're looking for a certain file, whether it exists or not, and that's the permission of the file. Okay. And let me get example 3 up. So in example 3, we see that it's using the Sys module along with the OS module because we have some arguments that we're passing here with the Sys. Okay. And then we're also using the path, right? The path from the OS module. So in our program, after we're getting, we put the if statement. If the argument is 2, right? The file name is going to be the second item or index 1, and it's going to print the file name. Okay. Then we also have a nested if here, and we're going to use the OS path. And we're using ospath.isFile. So here we are going to use the isFile method to check if that file exists. So this is a way that you can check to see if a certain file is stored on that system. And so if it is, if this condition is true, then it's going to print the file name. Again, we can use if not, or here you can also implement else. So if not, if it's not the same file name, then we would say that it does not exist. And if it's not able to access the file, and here we would use read OK, then we would say that it's access denied, because at the lowest level, you have to be able to view the file in order to modify the file. So then we would and this is what's built into the OS module itself. So we would say the attribute or the permission attributes is what we would state here. Okay. So when we run this, right, we would see it's not printing out anything because it would then need to require, it would require that it needs to match the condition. I don't have the second argument, so I don't have the file name, right? But if I specify a second argument, then it would print out my file. Okay. So that was the example from the textbook. That's what you see. So in my notes, I also included some information about get CWD. And this is a method to identify your current folder or directory. Which folder are you in? Are you accessing? So you can look at your current working directory path by using get CWD. And we can also list the number of list different objects inside that directory, such as file names and directories, the content of that folder, by using list dir. This simply execute the command ls in Linux, right? Or dir in Windows. So at the low level, right, it would translate to the instructions that will be equivalent to those commands. So we declare a variable called PD or PWD, and we are going to use the get CWD to get our current working directory and then store it there. Okay, so we can then, if we need to print it, we can print that out. Now, the list directory method, it's going to output a list, which is a group of items. So with that, we have to incorporate a for loop. So that way it would loop through and it would look at every single file or folder inside that current working directory. Same thing as you using ls or in Linux or dir in Windows. Question? So here's the show content directory. And when we run this, we would see that it first, right? It's gonna give you the list as it goes through. So it's gonna check your file name, check the directory, and then it's gonna give you the content of that directory or the folder. Okay. So I have a bunch of stuff in there. So if you don't have that many, so you can pick a certain directory to use. But now keep in mind that it's going to use your current directory that you're accessing, or you can also specify the path. Okay. Now, the next part, it touches on how you can use it in the OS module to do various things, like using system method. That's going to allow you to execute shell command. And so when we say shell, it really indicates the Python shell. Okay. Yes, it should be able to work on the Mac as well. Okay. Because on the terminal level, you should be able to get the directory very similar to what you can see with Linux. The best thing to really differentiate on which method is working with which, right? You know, some method might not work with some of the OS, because if that OS doesn't have a specific command, you're welcome, then you won't be able to incorporate that, right? So go to the documentation. Other questions? So now we can see that we can look at the shell, we can return a list of the content using listdir. And one of the most popular one with OS module is to do the walk, right? To use the walk method. And you can specify the path if you want to look at specific directory at a certain location. And it would also, we can use this very similar to list here in that it's also going to list, but in this case, it's going to give you a list of file names and the subdirectory in that path. So you can use list here to create a list. Now, list here is going to make a list of the folder content, where walk, it's allowing you to navigate through the directory. So it's going to walk through every single directory and be able to output which directory it had walked through. Okay. So then for example 5, we include the OS module, so we import that in. And as the folder might contain many items, so you have to keep in mind that when you write the script for that, you have to use a loop. Okay, so in this case, we're using a for loop. And when you write your for loop, you can say for root directory and files in, right? And we simply use the walk, and we're going to go from top to bottom, right? And after that, we're going to iterate over the files with the current root. So we would nest a for loop in there, and we would say for file entry in files, we are going to make a path to the file. So we're going to print, and then we would use the join, the OS path join method to show the files. Then we are going to loop through and show all the subfolder names. So this one gives you the file names inside the current directory. The next for loop gives you the directory names inside the current directory, all the subfolders inside the current folder. So there are several ways that you can use the OS module to look at the content of your directory. Okay. So here we would see first, right? It's going to walk through and it's going to check every single items in my folder, my current folder, which is my where I store this file. Then what it's going to do next is it's going to look at the path of it, the relative path. So in this, and notice that my temp files, it shows it with the tilde or the wiggly sign compared to my regular file, where it only shows it as the file and its extension. So on the last loop here, right, we would print files as the name. Okay. And so OS walk, it is a generator. It uses a generator function, so it iterates through, right, the container, which is a list of files and folder. Now with OS walk, you are going to return, you can return a tuple that would include the path as a directory name. You can also output lists of subfolders or subdirectory names. You can output non-directory file names, as you saw in the output there. Now we can also count up the number of items in that folder, right, by using another method. And here we would simply return the file name and the function and then loop through and count. So for example 6, did I put it in? I might have not included example 6 in my file. Let me go find it. Okay, so with this, we have OS module. We're using collections, right? And then we're going to import in counter. We create the counter object named counts. Then we simply use a for loop to make it walk through our current folder. And then we would have another for loop, and we can now examine the file. So the output that you see here is the file extension, which is the last statement that it prints. So you can have another for loop to look through all the items in that folder and count it up, which gives me 6. And that's a little different from my computer to yours because I have more files. So that will be 6.py. So you can quickly use this to also to be able to pinpoint or search for certain things, certain files or subfolder, subdirectory at a certain location. Okay, let's take a look at number 2 in your assignment. Number 2 asks you to write a Python script that contains the OS module, and it needs to show our current working directory. It needs to list the files and the directories using OS list. Then we also want to display the files and the subfolders. Then the third task is to make it walk. So we're going to use the walk method and the path method to list and display the subdirectories in the current directory. Okay, so B is about the list method. C is different than B in that we're using the walk and the path. You're still going to be able to strive for something similar or the same. And then D, we are going to list and display the file name, its extension, and the current working directory. So for number 2, it would look something like this. You can take some of the pieces from those examples and be able to incorporate it. And I wanted you to do that so that way you're more familiar with how to use, right, external module or module, and then be able to incorporate different methods for the purpose of your program. So to display the current working directory, I simply, just like the example, I use a variable here, and I would use the get CWD from, this is a method from the OS module, and we want to print out the current working directory. So that part is going to give us 2A. And then we want to display files and folder in the current working directory. And so we would have list directory is going to store, right, a list of the folder content. Then after that, it's going to iterate through and print out the subcomponent of that folder or the directory that you're currently in. So in 2B, I use listdir, and listdir return a list. So that's why we need to implement a for loop here, as it is a group of items in a container. Then again, for 2C, I also want to list the file folders in the current working directory, but for C, I want to use walk and path. So in the for loop here, we would say that there are potentially multiple things, right? So instead of nesting 3 for loops together, you can write it into one line. So you can say for root directory and files in, and we're going to make it walk through. And just like the example, okay, and every time that it's going to print out the little period or the dot, and we can use the same thing as the example. It will be top down is false. Then after that, we would make it iterate through the files in the current root. So for that, we would then use for file entry in files. Just like the example, we can print the plus symbol, the plus sign for each of the entry. And we are going to use path join. Okay. For the root directory. And then after that, we are going to list the name of the files using a for loop. Then for the last part, D, we can use the next example, and we're going to make it walk and count. So here we're going to use the collections package, and we're going to use the counter class from that. When you bring in the counter class, then you can create the class object, which is counts. And again, we are going to use a nested for loop. We're going to make it loop through, and it's going to walk through the content of that folder. And it's going to give us the name. And show the extension. So when we run this, it's going to be lengthy, depending on your folder. I will scroll it down shortly. I just want to show you the output. So the first line, right? This output right here is the path of my folder, which is unit 2. And that's what I got from these 2 lines. Then for the next part, we're going to list the content of that directory, and we're going to use the plus symbol to indicate each of the item. So as it loops through, right, as you can see, I have quite a few. So some of the things that are temp and not visible to the user, right, you should also see that as well. Okay. So that's the next part, and that goes up to here. So this is all the things that will be in my folder. Yours might be less. So then after that, what we want to do is we want to be able to look at the files and the folders in the working directory. And we want to look at the type of files and count them up. So I have 24 Python file. Oh, I'm sorry, I skipped this one. This one just indicate that what it's storing. So it's going to look at the name of the files. It's going to tell me those are files, file or folder, right? So it's going to find that. It's going to look for the files. Then the last one, it's going to give me a count for each of the file type. So I have 24 Python file, 5 docx, 2 text, and 1 zip. So these type of script also allow us to not just search for files, but be able to manage our files, right? And so on. So then you would be able to use the example from our notes to do exercise 2. Any question before we move to platform? Okay. And the program is fairly short, actually. It's just there are a lot of comments that were added. All right, so now you saw how OS module is implemented. And like I said, look at the documentation to see what other functionality that you can incorporate using OS. There are really cool things that or methods that you can incorporate in your programs. The third module that was introduced or explained to you in the chapter is your platform module. And this module helps you determine system information as well, but more specific to the platform of that system. Like OS's specific type. Now, the example that's shown on page 3 of your notes, this one, it is used in a way that where we want to identify a certain OS and be able to ping it. So you would start with an import platform statement, first line, and then you have it identify the system platform and store that into a variable, then print it. And then it's going to check if that platform is Windows, it's going to ping -n. And why we're doing this is because different OSs use different commands. So your command for Windows is different than your Linux or others. So here, if it's Windows, we're going to ping with a -n. If it's Linux, then we're going to do the ping count, and you would follow that with. So it's going to ping 1 time here, it's going to ping 1 time, count 1 here, and the IP address. And otherwise, it's also going to ping count 1, and then the IP address. Any question? That was example 7. So let me run that for you. So as it checked my system and yours, if you're using a different system, it's different. So it tells me that this is a Windows OS because I'm running Windows 10. And with that, it's gonna ping one time using ping-n and then using a loopback address 127.0.0.1. So in a network environment, we can, because you have a lot of different Cisco devices, and Cisco or network appliances have different OS versions. If you're using the older Cisco, it was a group of different OSs compared to the newer Cisco, right? So we can write a script to be able to identify a target system OSs, and then we would implement the conditions to execute a certain command for automation purposes, for task execution, for whatever it is, for connectivity. There are a lot of different things that we can do. So this is the base, is that how we can use platform module, identify the OS, and then use the command with appropriate OSs. So you can also use this to display more information about your Python version. Now the output of this is slightly different than what you've seen in the last module, where it would have, it would return in a specific way. So here it talks about the string return for implementation method. And then the version tuple is going to give you 3 elements of the tuple, which is your major version and the patch level for that package. And so in example 8, oh, that's different. Sorry. Okay, we can run this. Now I run this through the Python version in Tawny. So, and most of these interpreter or the IDE for Python, you would see that it will implement Python or C Python, right? Because it is really C in the back. So what you would have is here, it tells me that it implements the C Python. And then the version, it's version 3.77. So you would have the version number and then the patch level. And this is useful to be able to identify the compatibility of your Python packages and so on. Okay, let's look at number 3. For 3, we are going to use platform module, and we are going to write in our script, we're going to display our current OS information. And we're going to apply very similar to the ping command example. We're going to use appropriate commands for a certain OSs, but in this case, we're going to use ipconfig, IP address, ipconfig for Windows, IP address for Linux, and get IP address en1 for Mac OS for the interface one. So then we want to also display Python implementation and the version, very similar to the example we just looked at. Okay. So let me open my code. Okay, so we would start with import platform. And then we're gonna have the operating system variable. It's gonna store the output from platform system. So display OS. Then for 3B, we simply have the if statements. If the operating system is Windows, we would have it do ipconfig. If it is Linux, we would have it IP address. Else, it's gonna do this for Mac. And we want to print. So mine, because I'm using Windows, it's gonna show the command. Then for the Python implementation, you can just use the same as the example. You can display the Python implementation and the version with the patch level as a tuple, right? So when we run this, it tells me that my operating system is Windows. My command to find IP is ipconfig. Implementation is CPython. And my version of Python is 3.7.7. And yours will look slightly different as you might use another OS or. All right, so now what we have is we have this program for number 3. We're able to identify your OS version. We're able, or your OS type, I should say. Any question for 3? Okay. And the book also introduces the subprocess module. Okay. And this is where you're able to invoke or communicate with the processes like data input, receive output. So keep in mind that these modules, allow us to really interface with low level tasks or, elements. And they recommend that you utilize or test this in Linux systems or having, C compiler. So for if you don't have Linux system, you can use something like Visual Studio on Windows because that will have C compiler, and Linux has the GCC package, so that allows you to be able to test some of these scripts. So if you need to invoke a process, right, simply use a call method. And when you look at the example program, popen, this is in the subprocess module, it uses to start a new process that run with a specific command. Or we can terminate, we can kill a process to the command by using terminate method. And why is this important? Because you do have things like malware or activities that are happening at the process level. So you want to be able to control. It's very much like how you're using Task Manager in Windows, and then you right click the process and you kill the process. So what that is in Python for us here is we would incorporate the subprocess module and we would use the terminate method. Or if you want to invoke a process, right, then you use a call. So in example A, it shows you a way to ping. So we can ping a website with using popen. And that comes out of the subprocess module. So in this program, you would have import subprocess, import sys, and we define or we declare the command for ping. Okay. And it's going to be this string. Then we would put in the parameter for ping. It's like you're using the command. So this module allows you to break down the command and its switch, right? The parameter, the options for that command. So with ping, you have to say ping and then its parameter, how many times, and who is it pinging? Could be an IP address or your website there. Then the next object is P, and this is from popen. So you have to include, right, what command. So when you bring in popen, it associate that with the set of commands that they had identified or tied or associated with, right, from the subprocess module. Okay. So here what you would see is the command using popen, and we say that will be ping. And then its associated parameter and network. Who is it pinging and how many times? So then we would use the pipe for the standard error, and then we want to output. But it needs to decode that from UTF, and then it's gonna flush, which is clear. Okay. So let me get this. I don't know if I put, yep, that's the same one. Actually, this is a little bit more advanced. So if you have the textbook or you downloaded the source code, you can take a look at how you can specify additional criteria and make it do ping and scan, because they have an example of how you can do ping and scan. And this is the one that's included in the notes. Oh, yeah. So I'm running it on Tawny, so I cannot test this on here. You have to use the Linux version. Does malware always? No, it doesn't always have executable. EXE is only for Windows system. Malware can have other file extensions like .bat, .com. There's so many different type of malware, and there's a certain purpose for that particular malware. But for the Windows system, you would see it mostly if it's an executable file, it'll be exe. And they often use executable, but it doesn't always have to be executable. It asks exe. So as you can see, when I run this script, I would get the win error because like in the notes, right? I included that when you wanted to test this type of script, it's best to use Linux or something that would already have C compiler. Because it uses C, subprocess uses C in the back. So in order to use this library accordingly, right, we got to make sure that we have a C compiler. And my interpreter is not a compiler, so it's not a C compiler, so it won't be able to give me what I need for the script. So that brings us to the next question. It tells you that you can write a script for a Linux system that implements subprocess module, and we want to ping YouTube 4 times. If you want to test this, you need to use a virtual machine as Linux and write the code in it and then run it. Or if you're using Visual Studio, you can test it with Visual Studio. Just gotta make sure that you bring in the packages, like or the module that you need to use. So I'll show you what that script will look like for number 4. So we can use that example, okay? And be able to modify a few things in that example and use it for our assignment. So our ping is the same as we're pinging the parameter. Because it's Linux, we're going to do a count 4 for 4 times. And then the domain, we simply state which website that is. Okay. Very simple. You can reference the textbook example, the source code, or you can go to the notes. If you don't have that, go to the notes. And I had include the information in the notes. And the more lengthy example, as you saw with the parsing, that will be building the scanner. And so you can use that to check to see if your system is communicating. And we can automate a lot of the process too, right? You can have it, ping specific target, or you can have it ping a number of systems, a group of targets. And so when you look at something, a script that they would use in some kind of attack, right? All that is to take advantage of a weakness in the system and to really capitalize on it. So simply incorporate sometimes already made libraries, and then, we can have it continuously loop through and test different things or try different parameter and so on. Any question regarding subprocess? In our program, just like I said, you can use the example and modify it a little bit. And this one is okay not to be able to provide the output screen. If you don't have Linux virtual machine, that's fine. Okay. But we need to be able to write the script. Okay. So now we are going to revisit directory and files. And some of you learned this in 30A on how you would be able to make a file, read the lines in the file, and then close the file. So in file operation, first you have to open the file in order to see what's in it. Now, if you want to edit the file and store additional content to that file, you can use the write method. And in the first bullet here, write string, all that is write the string to the file. You can have it read to a certain number of bytes, not the entire thing, by using read and then specify the buffer size. So if you don't put anything, it's going to read the entire thing. If you put in the buffer size, it's going to read whatever that you put up to that buffer size. And the same thing with read line. And then after you access the file by practice, we would close it. So you have a close method. So now when we look at the example, in the first example, let me just make sure that it matches here. Yeah. We simply have a function or a method called main. I don't like to use main as a main name method, but this is from the book. So now when you use file operation, it's useful. It usually is with the with open statement. So you would see that it would say with open, and we want to open the file first. So you would have the file name. So here in this case, we would have a test.txt. And we would indicate the type of action that we want to occur in that file next, right? We want to write. So it will say with open file name, write as file. And then after that, we would specify the string that we want to write to it. So you would say write and then the text. This is the test file. Then we would simply call the function in the main. So you don't have to put if name space is main, call the function, right, which is main. Python interpreter automatically knows when you do the function call, but it doesn't hurt to put that statement as well. So with this, after we run this, okay, we don't have any output here, but what we can check is, do we have any output here, right? So you should see that this is the file and it appended the string that you specified here. Okay, so that's correct. Now at the simplest level, we should know how to be able to write a file using with open statement. I didn't have it closed here, or the book didn't have it closed here, but you can definitely close out the file. Another way that the textbook shows you is to use exception handling to check if the file exists or not. Okay. So in this function, we would see that we would use the try, except, and else statement. So we would try, we're going to try to open the file test.txt and write to it. It's going to append, this is a test file string to the file. And then we're going to handle the error. So we would handle the IO error. If it runs into the error, we want to print exception is caught. And then in the next except statement, line 7, it shows exception as E, and we want to display another error occurred, and so on. So when you get to the else statement, right, it would say, okay, file written successfully. So to handle the error in the case where it can't write to the file, it cannot save, right? You want to notify the user. And then lastly, we call on the function. So that's another way. Okay. And in example 11, it actually reads the file and then count up the lines. So you can use this in so many ways where you can seek for, you can add to the file, you can modify the file, and so on. So as we saw that with open statement is essential. Now, what happens when you have a zip file, right? Zip files are handled a little different, and Python has a library for that too. You can use a zip module to read what's in the memory. So when it's zipping your file, right, what it does is it modifies the file header to indicate that it is a compressed file. And with that, it changes the way that the storage is used, so the memory is used for that particular file, right? Ideally, compression is supposed to lessen, but not all file types are compressible. Some, even when you compress, it stays the same. You can also use yield to look at the file names in a zip folder, like what they've done here. So we would import zip file, that's the library we're using, or the module. Then we would go through and we define the list file in zip function or method. And then we would also access it and display the file information. Now let's go to our assignment and address the next question, number 5. Write a Python script that writes a string using Python to output text file to a text file. But in this case, we're going to use exception handling statement. Try, except, and else. We need to provide screen capture for that. So let's take a look. What happened? Number 2. Oh, it's wrong unit 2 I'm looking at, sorry. Been a long day. All right, so for 5, so you can use the example that's provided in the notes. We simply define the methods and then have it written to the file. And in my case, I use the file name exercise 5, okay, .text. And then when I run this, okay, it tells me that it's written successfully, so I can go and check. And so exercise 5 is here. I can open and I would see that it appended the string. Okay. Now, doing this, the advantage of exception handling is in the case you run into error, it's able to handle it, compared to the other way where we simply just define a function and we would write with open statement and then have it verify that it's stored to the file. So, you know, that will be more on the simple level compared to managing the exception. And we should always expect some form of exception anyway, right? Question? Okay. So this was not included in the textbook, but I want to include SH Util Module. This is a little bit higher level than what you've seen with, open, read, and close file. If you want to copy, archive, or remove file, this module is useful. So when you access that, okay, it gives you different methods on how there's a bunch of stuff on copy and so on. So this is another module that we can consider using if you're working with file operations, but higher level. So what header is changed when the Python is reading the file? So when it's reading the file, it's actually just reading the content of the container. In the header, it tells the system on the size. It modify the state of that file, I should say, not the complete header. Okay, so it modified the state of the file. Now, if you and you see this on the OS level. So for example, if I go here and let's say that I modify this, I can add this file to make it a zip file so I can make it compress. So simply when we give it an additional extension like this, right, or we can archive it, what it does is it changes the attributes of it to make it, this is going to put it into the A attribute. And then when you size it down or when you do the compression, what that does is it added the attributes for the compression. So in a way, it is modifying the characteristics of that file only. But as far as the location of the file, it doesn't modify anything outside of that location. It's still staying the same. How you're able to save storage is that because when it gives the archive bits, right, it's gonna be able to reduce the amount of space in that address that's using. So that way it would save, but that doesn't always happen for all file type. So when we're looking at something like things that are already pre-compressed, like the MP4, the MP3, it doesn't really change very much when you apply the compression or the zip. But if you looking at raw file or things that are larger in nature with, that's non-compressed, it definitely changed the attributes to reduce some amount of space, right? Okay, so let's take a look at the next exercise now. Okay, we're almost done. So we already addressed number 5. We're going to take a look at number 6. We're going to make a parent folder instead of a file. We need to go over that. And we're going to zip it. And we're going to use a zip file module to access the zip folder and its content. There's a few examples that it provides in the textbook, along with, I include some of it in the notes. And so you can see that now, okay? So in this example, when you are accessing the zip file, you would use zip file library or zip file module. And the way that you can read the zip folders, you would use the Util. So in the program, we simply import the zip file module. We have a function, and it's able to list the content of that zip folder. Okay. So now the way that we can approach this is we can use it like this to be able to access what's in the what's the subdirectory inside that, because when you have a child that's inheriting from the parents, this folder that's inside a zip folder also becomes zip, right? And then we would have it go through a loop. So here we would have a for loop, and we would call it, we would call the method. So as it loops, right, it's gonna zip. And this is just an example, so I want to show you. Okay, so when we zip this, right, it tells me that inside files.zip, which is my zip folder, I have these files. Okay, and we can check that. So here's my files.zip. I have those files. Okay, so it's able to read the content of the zip folder. Now, this example is missing one component, which is the child folder. Okay, so I'm going to show you how you can make a folder inside a folder through Python. What is it now? 5, 6, 5. Actually 6. And it's very simple, actually. Okay. So for number 6, we can say that, okay, first we are going to use the OS module, and we're going to import in the zip file. So we're going to import OS, and we're going to import zip file. The reason why I imported OS module is because I wanted to use the makedir method in OS to make a folder. And this is the same with make directory command in your command line, right? For Windows, it's the same, make dir. So after that, after I have created the folder, I wanted to print it to confirm that it made the folder. Then I have to zip the folder now, right? So if you're using the example, yes, you can create the zip, you can access it, but we have to make a folder. Okay. and then we're going to zip it. So we simply would use zip file and zip file class. So I have a ZF is the container or the object. And then I would use zip file. And in the parameter, I wanted to put the name on how I wanted to name my zip. So I simply say exercise6b.zip, and it's going to create it. So it's going to write. It's going to write to make it zip. Then after that, I'm going to use a for loop to access the folder itself, the zip folder. Everything inside it, I want to make it walk through. So I do an OS walk that folder, and it's going to list the content by using the right dir name. Then I would nest another loop. And here we want to use the path join and the directory. So after I'm done, I need to close it out, and I simply print the directory names. So basically you have a folder, you created a folder, you zip the folder, okay? And it's going to create the subdirectory within, then it's going to access that folder and give you the content. Now, before I do this, I gotta make sure that I don't have that existing file or folder. I'm sorry, folder. Because if you do, it's gonna throw an error. It cannot create it. It cannot create multiple instances of the same, right? It will need to be unique. So let's run this so you can see. So I made a folder, and then I had it print the content of that folder. Okay, so I'm going to show you now. It wasn't there before. So here's my unit 2. I now have an exercise 6B folder, and inside it, I have a child folder called the same name as it zipped it, right? It has nothing in it, of course. But this script allows you to make a folder, zip it, right? And as it does that, you would make another folder with the same name underneath, the subdirectory inside that. I wanted to do more with this exercise, like, so you can add more to it, right? Make a folder, add so many files, you can do with open write files to it, then you can zip it, and then, close it, and so on. But this gives you the overall understanding on how to use the zip file module with a folder that is either exists already, or you can make it in the script. Any question? We have about 20 minutes left, so that's going to cover the last part. I didn't really emphasize too much on the concurrent programming and parallel programming for this particular chapter, because that section alone would, in the advanced Python, we addressed that, but also it requires a lot more, right? I think the book only gives you the overall perspective of what a thread is and how, what kind of library you're using and what's a parallel process and so on. Now, if you wanted to make a different folder, you would then do a ZF, right? And then a different folder there. As it loops through, right, it's gonna walk through, access each of the content, and then it's gonna put the subdirectory in. So you can check out the script, test it. That will be, this is for 6. I actually wrote 3 programs for this. I ended up like scrapping like 2 of the other ones because this is probably the easiest one to see. So okay, any question on 6? Okay. So in our notes now, after these modules for file operation, it's going to go to thread. And threads are just streams, right, that we can schedule. So the way that we can use thread is we can make it time in the OS, okay, where it can be executing using one core processor, and it will be executing together. So the time element in thread is really important. We can also have multiple cores to handle the threads simultaneously. So when you want to write a script for threads, you would use threading module. And I know those of you who took 30E already, you are familiar with this because we spent quite a few weeks on thread and processes. Okay. So from that module, you are going to use the thread class. It is the superclass. And in the with the thread class constructor, there are 5 arguments: group, target, name, args, and KW args for dictionary. So the args is for regular arguments or argument tuple compared to KW args. That will be your dictionary, and it uses key and value, right? So that's why it's different. When you work with thread, if you want it to execute, you use a run method. If you want it to wait for the other thread to finish or do a block, you would use join. There are 2 main types of threads. There will be a kernel level threads, which are inaccessible to the user. You cannot interact with it. User level threads are higher, and the users can interact with the user level thread. And if you want to find out more, of course, you can use the help option in Python. So for exercise 12, it shows you how you can create 4 threads. We import threading. We import the time to measure the time that it executes. And we specify that there are 4 threads. And we're using the variable num threads here. Now in the functions, because there are a number of threads, right? You want to be able to define a function, make sure that it has the global, right, variable. You bring that in, and then you would decrease, because as we execute, it will count down. And have a while statement. When thread is greater than 0, you would just keep going until it gets to 0, then it's going to stop. And in this case, we're simply just going to wait. So the key thing in this, right, is the statement right here. Okay. So after all of that, this is the key statement, is you are going to use threading and the thread class, and then its parameter or the arguments. The target, which is which is the thread. And then with that, I wanted to print out some information. So it's going to initialize the thread it's gonna pause for 0.1 of a second, and then it's gonna loop again for the next one. Okay. And thread, for most part, we can make it where it would be sequential if we're using one core processor, but if you have multiple core processor, you can make it, each of the processor would handle each thread, or each core, I should say, handle each thread. Now this one you can run in the interpreter, but when you work with processes, you have to use C compiler. Okay. So this is the example from the text, and we can run. So as you can see, right? Now, when you look at the output, you would see that it would not, so we would start with 4, we go down to, because we decrease here, right? 4, 3, 2, 1. Okay. So it's going to load the 4th thread, wait 0.1 second. Then it's going to target, while it's waiting, it's going to target thread 3. Then it's going to load that. It's going to start that. Wait 1.1 second. Load thread 2. Wait 0.1 second. And then lastly, the last thread, which is thread 1. Now, in concurrent programming, we can make it where it doesn't have to be like this. It doesn't have to be sequential, in that we can have it going from thread 4 to thread 1 to various threads, right? And that's another topic for another class for 30E. So this just gives you an overall view on, in the back, how we can have the program execute a certain way using threads. And threads and processes are usually implemented for multitasking. Okay. Heavy load multitasking. All right. So for 7, we can simply take the information that's provided in the notes. Kernel level threads, low level threads, we don't have interaction with it. User level thread, high level threads, we can have interaction with the user level thread. Kernel is protected, right? Once in a while, you see malware cases where it impacts the kernel, but it's the way that the system's design is, your OS kernel is protected. So we will never have, that's low level, right? So how we interact with the hardware is you would have the hardware abstraction layer. And then, so that's because if you have interaction with the kernel, right, there might be impact in the kernel where you would change it, and that can cause a lot of issues for your system. So the way they design it is make sure the kernel level is, the low level is protected. For question 8, the difference between using a threading module and a multiprocessing module is that your threading module is used for threads, whereas multiprocessing module is used for processes, multiple processes. And there are other libraries that you can use for processes as well, but these are the 2 common ones. Okay. So you can write a program that has multiple threads. You can write a program that also have multiple processes. And that's considered under the parallel programming. And you will find all of the details also in the notes, right? Multi-threading. So multi-threading in application really allows us to create additional threads, which are copies of the codes, and be able to execute them at once. And with that, we want to make sure that things are loaded and execute at the same time, so it reduces the time that it will take to complete the task in that program. So let's think about it, right? If you have 4 threads, let's say the program have 4 tasks, and you divide that up to multiple threads, you can handle it all at once. That will be quicker than going from task 1 to task 2 to task 3, task 4, task 5, and so on, if you have many threads. Now, we would have multiprocessor to be able to handle multi-processes, right? So all your cores now have, let's say if you have an i7 or an i9, you might have a 12 core, or 4 core, or 8 core. So you can dedicate 6 out of the 8 core to handle the processes, and that will reduce your execution time. We can make a group of threads that's called thread pool, and this is shown here. Okay. Now, if you pay attention to the program, once you have the thread initialized, right, you need to have it start and then, or run. Okay, you can also use run. And if you want certain things to wait, you just use join. And what that does is it's going to wait for the others to finish before it loads. And that allows it to block it from completing before other threads would finish. Okay. And so we want to make that synchronization process and apply that using those methods, and also time mechanism. You can have it wait a certain time and so on. And I didn't expand much on the multiprocessing part, because with that, like practicing these takes time, okay? And also you need to use C compiler to be able to build out those programs. So I want you to have an overview of what things are. So when you write this for security script in our next few chapters, you understand how that works. Okay. So we'll focus more on writing script with the libraries for security purposes. So now in the book, the last part of it in the chapter, if you do go all the way to the end, okay, after threading and processing, it touches on WebSocket. And next chapter, it's going to emphasize a little bit more on WebSocket and HTTP libraries. And this is the area that is important to us in IT and security. So WebSockets provide real-time communication for connection. This just reduce the amount of work that we need to make sure we need to ping or identify who's connecting. So that allows us to use full duplex. That means that send and receive simultaneously, and also real-time communication. And most of our things are now, right, needs to be real-time for applications, for, overall communication, voice, and so on. So the two modules that are essential in the WebSocket area is Async Io, which some of you have seen if you've taken 30E and also 30B. Also in 30B, we also touch on the AIO HTTP. This is used for client and server to establish WebSocket so that way it can communicate to like database or asynchronously, so it doesn't have to be synchronizing in communication or other things. And you would see these modules also being utilized in the cloud quite a bit as cloud support a lot of web resources. Okay. Now, I only pulled one of the example because I think that it's more important for us to focus on the next chapter where we would have a little bit more practice in the web area. So the Socket IO is one of the library that you can use. And this particular program example 14 is just to establish client connection. So here we have an object called SIO, and that object is used with the decorator for the event and the connection. So you can define some of the customized method to be able to see, who's connecting what, or you can simply use a built-in method like connect and point to which server that you're connecting to. So in this case, I'm setting it up for the client and it's going to connect to this domain. Okay, which is the local host. And then we can initialize some kind of message there. We can also have it pause. Wait, method is a pause. Excuse me, and so on. So this type of skills and knowledge like scripting, right? It would go beyond just to do, server administration or web server administration. It actually expand in the area. We do need to test connection for IT. We also can examine and do investigation for security side. So having the knowledge on what kind of library to use in your Python script, what kind of functionality you can incorporate from those modules is essential. And so this is the class that's introducing you to options to building out your tool for security, right? And okay. All right, so I am finished now. That comes to the end of chapter 2. If you do have the book, please read it and then complete the assignment and turn it in. And I will try to update your grades throughout tomorrow and Friday, as this is a short week. Okay, and so we'll meet again on Monday and we will address the next chapter on Monday and then do the lab on Wednesday. Okay, any questions? Thank you, Michelle. Put your name into the chat.